from the aspect of pulmonology topics. Now we all know that cystic fibrosis is the lung disorders, so we just function in under the pulmonology. Okay. What type of the problems are there? What is the physiological conditions for which there will be some, pathogenesis? We'll talk about all the things here. So basically, the cystic fibrosis is the most common. It's found the most common in children, the white peoples. White people. Okay. It's just like this. We can say within the European countries, or the European, the Western countries also. We can just define just like this. Out of 3,000 children, one children is having the chance to get affected by this cystic fibrosis. Okay. So what is the main problem here? The main problem is the main positive things is here that the mutations. For the mutation in 7th number chromosome. The 7th number chromosome there is a gene, which genes if you see that the mutations of this particular gene, then this gene will be responsible for causing the cystic fibrosis disease. Okay. So for understanding these purposes, we need to know where is the pulmonology. So let's draw a lungs. Just simple diagram. Drawing is not that much good, but for understanding purpose, I am just drawing it. We all know that within the what is the tracts, respiratory tract. We know there is the presence of mucosal epithelial cells. Presence of the mucosal epithelial cells. Here also. Okay. Now we'll talk about particular cells, mucosal epithelial cells, because they are the mutations of these particular cells in the 7th number chromosome will be there. So we'll talk about all the things here. Okay. So I'm enlarging a particular cell here, making it large. So let me make it large. This one. Okay. Now within the cells, within the mucosal epithelial cells, there's the nucleus. Obviously within the nucleus there will be what? Chromosome number 7. So it's the chromosomes from the paternal, from the fathers, and the maternals. Okay, from the mothers. Now as you know, it's what? The mutation is autosomal recessive disorders. So both autosomal recessive. What's the problem here? We need to know first. So actually there is a gene that is present in the both homologous chromosomes. The locations of the gene that is, I am writing it here. 7 means 7 number chromosomes. Q means the long arm, 31.2. That defines that 7 number chromosomes. Q means what? The long arm. 3 means, region number 3, region number 3 of the allelic positions. 1 means, this 1 means band number 1, and 2 means subband number 2. Okay. What's the problem here? So there will be, okay, so there no fun in telling, there will be also within the chromosomes there will be the DNA. Actually the locations of these genes basically may be here. Okay, just like this. Now this gene, under the process of transcriptions, it will produce a mRNA, and this mRNA will come outside within the cytoplasm for translation purpose. Okay. Now let's suppose I am drawing the mRNA here. Okay. And within the mRNA there will be what? Sequence of nucleotides. There will be the sequence of nucleotides, along with you will see the ribosomes. At first I will talk about the physiological conditions. Okay, what happens under normal circumstances, then I'll talk about the pathologies. So these are the ribosomes, and this is the mRNA. Now, you know the gene, for the gene another protein will get the tRNA. So with the RNA will get the tRNA. This tRNA will come and it will help to produce from here, it will just do translate and it will produce the amino acids. The sequence of amino acid will get here, just like this. Okay, the amino acid will get here. Now after forming these amino acids, these things, there is the linear chains. Okay, there is a sequence of the linear single chain of the amino acids. So sequence. Now this thing will be taken by the now what? The endoplasmic reticulums. No, just like the endoplasmic reticulum. Okay, because there is the rough endoplasmic reticulum. Okay, after taking it, actually there will be the proper foldation. Okay, this is the protein. Let's suppose we got these proteins. Okay, we got this protein. I'm just denoting this red one with the black one, and there will be proper foldation for folding purpose. Folding of protein. Okay, after the proper foldness, we'll see these things will go through the. After that, it will go to the where? In the Golgi apparatus. So it will go within the Golgi apparatus. After going within the Golgi apparatus, there will be proper formations, all the properties of packaging, storing, all the things will be there. Golgi apparatus. Now what we see here, that after going within the Golgi apparatus, this protein within the Golgi, after formations, this will do the vesicles formations, and this will come within the vesicles of the Golgi apparatus. Then it will leave it. Then we'll see this protein will get attached here within the membrane. This is the protein. Okay. Now I'll show you how the protein works here. Okay. Now, so if you want to see this one, let me just erase this part. Now also this protein got stuck on the membrane. Also the further steps, whatever the physiological things are here. Okay. Just like this. So the proteins, we got it here. If we see the structures of the protein first of all, so the structures of the protein will be just like this. It will have the two transmembrane part, both of its sides, and in these sides it will have extended part, and it will have also one more part here. Okay. Okay. Now just okay. Have some reactivities. Now I have to know what are the functions of this protein. Okay. Now as we know, these proteins are known as a transmembrane protein. They're known as transmembrane. Transmembrane protein, similarly also transmembrane protein. Okay. And it is known as the regulatory protein. I'll say Y. And we are seeing these things, that there is presence of this type of the things like the growth. These are responsible for kinase. Kinase means they will attach the phosphate. Okay. And one more thing here, there is the presence of, for this person, there is presence of attachments, place for the attachment of the ATP similarly. So you can say it that we know that ATP it's like the nucleotide, so nucleotide binding domain. Similarly, we can see nucleotide binding domain here also. Okay, so there will also get bind with the ATP. So by the utilizing this energy, it will work. Now, what's the function of this thing? And we have to know this thing also, that on these sides there will be also on kind of the channels there is a sodium channels. The sodium channel. Whatever the functions we will see, actually whatever we are seeing this transmembrane part, okay, then we are seeing what this regulatory protein part, then we are seeing this new nucleotide binding domain. All the three things together they are known as. This whole complex is known as cystic fibrosis. Transmembrane conduction regulatory protein. Okay. So CFTR proteins, and the gene that is responsible for here, that is a CFTR gene. It is a CFTR gene. Okay, for this the dysfunction of the, if you see the any kind of a mutations there, for these things we will see. But I am talking now only the physiological conditions, then I will talk about all the things later. Okay. Now we should not forget this thing, that the functions for this complex to expel the chloride outside. Okay, the functions for these things, this regulatory proteins of this whole part, there is a part also the regulatory protein, that is a part of the CFTR protein, that will regulate, that will what exits, that will what sends the chloride outside. Okay. And another function for these things, this part like the nucleotide binding domain, that will cause what, it will inhibit the sodium intake in these sites. So it will just remove the intake of the sodium in these sites. Now if we see in a nutshell, in another diagram, just see it here. Let's suppose the epithelial cells. Okay, let's suppose the epithelial cells. Now what do we see here in this case, that by the functions of the CFTR protein, we see the chloride has come out here, and it will also inhibit the sodium channels to go inside. So sodium can't come outside, sorry, inside. Okay. So whenever the chloride is there, then the sodium is there. So we will see the formations of the sodium chloride. So Na plus Cl minus. So it will attract the more amounts of the molecules of the water along with it. So it will attract the water molecules. So it can hold the water molecules along with it. So it will hold the sodium chloride to hold the water molecules along with it. And we all know that what this thing will secrete the mucus. This will secrete the mucus, because these are the mucosal epithelial cells. As a result, we will see the mucus that will be thin. Mucus will be thin and not that much thick. Okay. Then what type of the problem we will see? If it is thick, if the mucus get thickened, and what type of the problem we will have, that is actually the cystic fibrosis disorders. Okay. Now this is the normal how the CFTR proteins works here. Okay. Now we'll talk about the dysfunctions, if we see any kind of the mutations there, then what type of the dysfunctions we will see, or disorders we will see. We will talk in the subsequent parts. Okay. Before that, let's suppose within the lungs, we know that these are what the ciliated epithelial cells. Right? These are the ciliated epithelial cells. Now this will produce mucus. I already said that this will just transport the chloride also. It will not let the sodium to come in. As a result, it will just hold the water molecules along with it. As a result, you will see there will be like the thinning of the mucus will be thin here. Okay. So let's suppose the mucus is thin. I all know that is having what, the cilia. These are having the cilia. These are having the cilia. Cilia. Okay. Now what will we see actually? There the mucus will be here. Now whenever for any foreign particles, we will see foreign particles. It may be like the bacteria, it may be bacteria, it may be fungi, okay, or it may be like dust particles. Let's suppose the mucus, like the mucosal cells, and the mucus is here, and whenever these dust particles, or we can say the bacteria, fungi, they will come here. Let's suppose the foreign particles, they will get stuck here. They will get stuck here within the mucus, and by the actions of the ciliary, by the action of the ciliary part, they will just what, ciliary opposite directions, and this what, all types of the foreign particles, the cilia will move all the foreign particles upward. Okay. So we will see that all the foreign particles, they will come towards the larynx. Actually the larynx is there, I am not drawing that much. Okay. So the larynx. After coming there, we will see that after that there is all the things that will be sent to the, let's say, the esophagus. From there it will come within the stomach. That will come within the stomach. After coming here, we will see within the stomach all the like the bacteria, by the actions of the HCl, by the action of the HCls, all the bacteria of the foreign particles, they will get destroyed. They will get destroyed. So basically every day we near about 1 cup of mucus we just swallow. We swallow every day 1 cup of the mucus every day. That means all the like the mucus, they will go within the stomach. After going in, these things will get destroyed. Now if the mucus don't come within the, sometimes we see just like this, and we just what, throw the mucus outside. That is known as sputum. Okay. Now these are the normal functions and the mechanisms how the cystic fibrosis proteins works here. Okay. Now we'll talk about the pathological things. So the mucus, I am repeating once. So if let's suppose any foreign regions, these foreign particles has come, because there is no ciliary activities, there is no like epithelial cells within the alveolar. So by chance if the foreign particles that comes within this part, then we know that there is having what, there is the alveolar macrophage. The presence of the alveolar macrophage that will engulf by the process of phagocytosis. They will just destroy the foreign particles here. Okay. So these are the normal things on the normal mechanisms under physiological conditions. That means right now, all the functions are going within the what? Within all the lungs, within this respiratory tract pad. And this tract pad, these other things are done by what? Mucociliary clearance mechanism. The thing is here, we need to know that is the, by the action of, we can say in a word, there is the mucociliary clearance mechanism. Now by these mechanisms, all the times, consistently, or this mucuses, whenever the foreign particles are coming inside, by the actions of the ciliary activity, they are pushing all the foreign particles upward. And after that, we are just taking it in the solvent part, and then coming within the stomach. By the action of the cell, all the things are getting destroyed. Okay. So this is the normal part, how the physiologically functions we see. Now we will talk about the pathological in the subsequent videos. So if you are new, just do subscribe and support me. Thank you for watching.